Welcome to this second lecture of the first week of the machine learning course. The theme for this lecture is Foundation of Artificial Intelligence and Machine Learning. The purpose of this lecture is not just by a single phrase or a sentence, but through a more substantial narrative, convince you that artificial intelligence is not a new hype. It's an old, established area, a sub-area of computer science, which has a long history. And from the beginning, when this area was founded, also that machine learning already at that time formed an integral part of the area. So, artificial intelligence as a research area has 62-year-old roots. It was established already in 1956, where a small group of researchers gathered at Dartmouth College in New Hampshire, US. It was just a summer workshop during 6 to 8 weeks that year. And as you may can infer, this happened only 10 years or less later than the advent of the first computer. So why did this workshop take place at this point in time? So short time after the birth of computer science in general. Part of the answer could be that the bulk of the work in the early days of computer science became focused on very low-level matters, where one tried to apply the new computer tools on very standardized tasks. In contrast to that, a lot of the people who were instrumental in the development of computer science already from the beginning had other ambitions and other visions, and that they probably very strongly felt that what they really intended with the new computational devices didn't really happen. Not the exciting things they wanted to happen, but rather applying the new computers to very much day-to-day use for standardized things. So probably after this decade of preliminary work, they thought that maybe it's time to raise the flag again, to raise the flag for the original ambitions for the use of computers. Essentially, that the potential of computers is to do very advanced things, and that this should be put up very high on the agenda again. So at this workshop, the group of researchers who gathered there, they managed to make a defining statement for the area, for artificial intelligence, which they agreed on. And that statement I will go through together with you, because I think it's an important statement, and a lot of what is said there still holds. So the statement starts: the study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. One part of this first part of the statement that is good to observe on a course of machine learning like this is that the first example given of these kinds of features of intelligence that one wants to mimic and simulate is the aspects of learning. So the statement continues. An attempt will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. So similarly, in this course, it's interesting to observe that there are two items in this list that relate to learning. First, number 2, which is to form abstractions and concepts, and number 4, improve themselves. So even in the second paragraph of the statement, learning takes a major role. The statement ends with a kind of funny paragraph, which goes as follows. We think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. It's kind of funny because after 60 years, we haven't really made significant advance. We have made some advances, but still significant advance, I would say, we will still wait for. But the ambitions at this point in time was very high in this group. So now let's take a look at the people who met at this summer school. They have been called the founding fathers of artificial intelligence. One of them, Claude Shannon, is the founder of information and communication theory. And he published his seminal work on that in the late 1940s. He's also, you may know, known for having published and written the most famous master thesis in the history of computer science, which was a precursor for his later publications in information and communication theory. G.M. Mackay was a well-known British researcher who already at this point worked on the borderline between information theory and cognitive science. Julian Bigelow was the chief engineer for the von Neumann computer at Princeton in 1946. The IIS computer, or as is more popularly was called, the MANIAC. Nathaniel Rochester, author of the first assembler and a key person in the development of the first commercial computer, IBM 701. Oliver Selfridge was been named the father of machine perception for his very early work on trying to automate processes similar to the way the human vision system works. Ray Solomonoff, the inventor of algorithmic probability, and one of the key persons that very early understood the importance not only to try to create practical learning system, but also understand the theoretical limits and restrictions of these processes. John Holland, the inventor of genetic algorithms. Marvin Minsky, one of the key MIT researchers, the founder of the MIT Early Lab, who were very influential in the early development of AI. Alan Newen, the champion for symbolic AI and inventor of many central AI techniques. His colleague Herbert Simon, who was a pioneer in decision-making theory and a Nobel Prize winner in economy. And finally, John McCarthy, the founder of the Stanford AI Lab and the inventor of the Lisp programming language. So not only the Dartmouth College summer school happened in the 1950s, which is or what is of relevance for artificial intelligence. A lot of early work already occurred in this decade. I will first mention a few general things that was important for the development of artificial intelligence as a field. So, unfortunately, one of the key persons from the computer science era was not present at the Dartmouth College, Alan Turing. But already in 1950, Alan Turing had published a paper called Computing Machinery and Intelligence. And the program proposed in that paper have been of very big importance for the development of artificial intelligence. And also in that paper, automation of learning was given a prominent role. Another result that was very early, even before the Dartmouth conference, was the work at Carnegie Mellon by Alan Newell and Herbert Simon on what is called the logic theorist. So the logic theorist is a computer program who tries to mimic the problem-solving skills of a human being. Actually, it's been called the first artificial intelligence program ever. The purpose of that program was to be able to prove theorems in Whitehead's and Russell's Principia Mathematica. And this program, even though some of the techniques wasn't even named at that point, introduced techniques that later had a big importance for the area, such as list processing, means ends analysis, and heuristic search. So this was a key research coming very early. Later in the 50s, Simon and Newell continued that work when they published results of what they call the general problem solver, which is a computer program intended to work as a universal problem solver machine, which of course then was in some way weaker than the logic theorist because it wasn't so dedicated to one kind specific category of problem, but was a wider range of applicability. Also in the 1950s, work started on defining programming languages which could be specifically useful to develop artificial intelligence systems. And in 1958, John McCarthy created the first version of Lisp, which had that purpose. Today, it's the second oldest high-level programming language still used. Only Fortran is older by 1 year. The final result I want to mention is that Oliver Selfridge, also one of the Dartmouth participants, created a system that he called Pandemonium, which was the first attempt to create a computational model that can mimic pattern recognition of images, of course inspired by the models at that time of how the human image recognition system works. So what is interesting to observe is on top of the early work I just described in artificial intelligence, there is a substantial list of things happening in this first decade that is essential for machine learning. So maybe first it's appropriate to mention the person who coined the term machine learning. That was Arthur Samuel, and he did that in 1959. And Arthur Samuel worked at that point at one of the IBM research labs. And one of his tasks there was to look at computer programs that could play checker. So this is one of the first examples of game playing programs, actually. And in the context of this work of producing a program that could play checker and compete with human players, obviously he observed that he needed learning algorithms. So he included in his system some learning mechanisms. And when he published these results, he was the first to use the term machine learning. Going back a little, actually before the 50s, the real starting point for work on neural networks was as early as 1943, when McCulloch and Pitts published their work called Neural Networks as a Model of Computation. So this was actually the first attempt to look at how we view neural activity in the brain and try to mimic that in a computational model. So this was very early, but actually this work also was followed up in the 1950s. So people like Marvin Minsky did some work in the mid 1950s on a system called SNARK, which is assumed to be actually the first really computer implementation of a neural network machine. And not much later, Frank Rosenblatt published his work on the perceptron, which is today considered the starting point for the artificial neural network development. He was working then at Cornell Laboratory. It was a very successful work at first, but it turned out that the way at least Frank Rosenblatt presented the perceptron and the initial applications had severe limitations. So after that, it took a time since that area really got the pace. Not much later, there was another kind of work focused on sub-symbolic representations. So John Holland introduced in 1960 his first work on genetic algorithms, inspired not by neural activities, but by Darwin's theory of evolution. So this was an even bolder step to look wider for the inspiration for computational models. And finally, also in the mid-1950s, Ray Solomonow published his first work on machine learning, which where we had a system which is termed inductive inference machine. And as I already said, Ray Solomonow became one of the key persons not only to look at practical application of machine learning, but also on the theory of the field. So, to sum up this lecture, the first point is that this lecture wanted to convey to you what kind of agenda the area of artificial intelligence had when it started 60 years ago. The second point is that already from the start, machine learning had a key role in the development of this area. The third point is that many of the kinds of machine learning we see today had its roots already at this time. So there were several contributions initial contributions to development of neural network at this point. There were several contributions to symbolic computation and learning in symbolic representations already in this time. And even this kind of machine learning algorithm based on evolutionary theory had its roots at this time. And finally, machine learning theory also originated at this time. So thank you for your attention, and the next lecture in this series will continue to give you a picture of artificial intelligence and the role of machine learning. Thank you.